We're going to carry out this project on aided observation task B11, which is called Demonstrate the Range of Objects in the Messier Catalogue. So I have prepared this Word document to help you to do this project. And what we're basically going to need to do is to just fill something in each section. And if we do that, then that will be adequate evidence that you have carried out this project. So the first question that I'm going to ask is, has anybody found out the answer to this question? What is the Messier catalogue? So can anybody give me an answer to that question in the chat? Or if you can't, say no. No from Matilda, and no from Leela. Okay, well, what we need to do first of all then is just basically look up what it is. We don't need to make up our own explanation or definition. Let's just do a search online and find a definition of it, and then we'll put it in there. Okay. So a Messier, this Sky at Night magazine one, I think might be a good one, or I might go back to the wiki one. I think I'll go back to the wiki one. I think I made that mistake last time as well. Okay, so here's a good definition of what the Messier catalogue is. Okay, so you can see the Messier objects are a set of 110 astronomical objects catalogued by the French astronomer Charles, if that's how you say it in French, Charles Messier, in his Catalogue des nébuleuses et des amas d'étoiles. So it's a catalogue of nebulae and star clusters. Now, in the days when he made this in 1780 something, nebulae just meant anything fuzzy, like a fuzzy patch in the sky, because the telescopes weren't powerful enough to see the structure. So that's all he was doing, was making a list of all the locations of where these objects are, and he found 110 of them. And by accident, he kind of found 110 of the best, what we call deep sky objects to observe with a small telescope. You don't need a particularly large telescope to see these, but if you've got a larger telescope, it helps. And they just appeared like fuzzy patches, and they were kind of interfering with what he was trying to look at, which was comets. So he was making a list of parts of the sky that you shouldn't look at if you were looking for comets, and accidentally had found a list of the best things to look at if you've got a more powerful telescope. So all we need, you don't need to make this up, we just need to make cut and paste some of these definitions out of this definition here. So I think I would just copy this bit out, and we'll put that into, I would put it into mine. You can write it in your own words in your document if you want to, okay? But something that defines what a Messier object is, because if we're going to demonstrate the range of objects in the Messier catalogue, we better know what the Messier catalogue actually is and what we're looking for. Let's see if there's anything else interesting here that we could put into that explanation. Yes, we could put this catalogue of objects, one of the most famous lists of astronomical objects, and many Messier objects are still referenced by the Messier numbers. Okay, I think even the last bit is quite good. So the catalogue includes most of the astronomical deep sky objects that can be easily observed from the Earth's northern hemisphere. So that kind of sums up what the Messier catalogue actually is all about. So I'm going to copy that and put it into my my document as well. So what do you think, Matilda and Leela? Do you think that explains to you what the Messier catalogue is? Do you feel that you understand what it's all about a little bit more clearly now? Yeah, good. Okay, now being a good scientist or any kind of researcher, actually what I should do is put in the source of my information so that people can't accuse me of plagiarism, and because if I want to go back to it, I will know exactly where to look for it. Okay, so I'm going to put that in there just for good practice. So what you can do, you can either cut and paste that exactly the same way, or you can just paraphrase it into your own words, whatever you want to do. Okay, but we need to know what the Messier catalogue is before we can start looking for objects that are in the Messier catalogue. So how are we with that? Have you written down what you need to write, or do you need a little bit of time to catch up? Bit of time, okay, that's fine. And if you don't need any more time, Leela, you could always go on and start thinking about listing all the types of objects that are classified within this catalogue. So what are we looking for? Okay, so Matilda, if you let me know once you're ready, then we'll go to the next bit. Okay, good. Yeah, I understand that. That's fine. Okay, Leela, happy for me to go on? Yeah, okay. Right, so let's go back to the Wikipedia explanation to find out what we're talking about here. Now, this image that they've got here is quite nice because this is a chart that somebody has made of photographs of all the Messier objects. So this could help us to start off with to make a list of the different types of objects that we can see here. So let's have a look if we can identify what we're looking at. I'll try and start with some of the easier ones, and then you can type in the chat if you can spot what type of object it is. So for instance, if we look at, I'll enlarge it a bit, and if you can see where my mouse is moving around there, what type of object do you think this one, number 51, so this would be called Messier 51 or M51 in the catalogue, what type of object do you think that is that we're looking at there? Right, Matilda says it's a nebula, question mark. Okay, remember, look, it's got some spirally structure to it. Leila says it might be a galaxy. So what do you think, Matilda? It's got these spiral structures in it. Yeah, okay, so it's a galaxy. You can see some other galaxies. Here's another one. This one's partly on its side. This one's completely on its side. So they all look different depending on the angle that we're viewing them at. Okay, but if we go back to that question, okay, list all the types of objects classified within the catalogue. So the first type of object that Messier had observed, although he didn't really know they were galaxies at the time, is a galaxy. And an example would be that one we were looking at, which was M51. Okay, so that's an example of a galaxy in the Messier catalogue. So let's go back to the image and see what else we've got in there. Let me find another type of object. Now, M57 is quite an interesting one. Any idea what that might be? This one here with the 57 number. Nebula? Leela says nebula. What do you think, Matilda? Yeah, okay, you agree. Now this one is a particular type of nebula because at the center of it you can see a dot, which is a white dwarf star left over from the explosion, the nova explosion of the star. So this one is called a planetary nebula because it's got this planet-like object, which turns out to be a white dwarf star actually, but at the center of it, and then all the gas and dust that's been blown away by the explosion. So if we go back to our list, another type of object that we can see in the Messier catalogue is a planetary nebula. E.g., what was that one? Forgotten. M57. Okay, so M57 is a good example, just so that we're making a kind of list of what these things look like, and just showing examples of each one within there. So we've got those. Now let's see if I can find, as you can see, there's lots of different types of galaxies. Right, M16, this is quite an interesting one. So M16, or even M1, you can see there's a few in this image. M16, M1, M17 are all examples of this type of object. So what do you think those are? 1, 16, 17? Any ideas? Have a guess? Yeah, it's still a nebula, but there's a different type of nebula. This is a diffuse nebula. So if you look, if we go and look again at 57, you see that it doesn't fill much of the image. And what you need to remember with all of these images is they were probably taken with the same size telescope. This one fills the whole image and is even spreading outside it. So it's a much bigger object covering a much larger area of space. So these are diffuse nebulae where they don't have that structure, that ring-like structure. They've just blown lots of gas and dust into space, and it's just like in a big cloud. This one, M1, is very famous, which is the Crab Nebula. The reason why that one's so famous is that it started forming in 1054 AD, and we know that it started forming then because Chinese astronomers recorded a new star in the sky, and they actually saw the supernova explosion that caused this nebula. And so ever since then we've known that it started forming in 1054 AD. So we know how long it's taken to get to this structure. So it's one of the most studied objects in the night sky by professional astronomers, because it's really interesting to see what happens to it. And we know, like a stop clock, we know exactly when it started, which is amazing. So let's go back and put in our list diffuse nebulae. So these are the things that just look like patches of like a fuzzy patch in the sky. Okay, so we had a few there. We had e.g. M1, M16, M17. There's a few of them there. Right, let's see if I can find now the other two. Let's see what you make of these. Now, first of all, number 2, number 3, that's a good example of the next type of object. Any idea what number 2 and number 3, number 15 is another one, what these might be? Whoa, well done, Leila. It's a globular cluster, exactly. So you can see it's a cluster of stars. All these stars are actually very close together in the sky on kind of galaxy, universal scales, but they're pulling together. They're close enough that their gravity is pulling them together, and so they are a genuine cluster. It's not just that they look like they're in that part of the sky. They're all very close together. You can see they're being pulled towards a center. If you look at number 3 in particular, you can see that there's a lot of orangey red stars in there and around the edges of number 2. And that's because they tend to contain quite a lot of old stars, and you can tell something about their age. You see that number 2 has brighter, sort of more bluey colored stars, and number 3 has more of these reddy orange stars. So we know that number 3 is older because the stars have developed into red giants and red supergiants. So that's a way that you can try and estimate the age of a globular cluster. So we'll put globular cluster in there as another example. Globular cluster, so we'll put e.g. M2 or M3 are good examples of that. Right, so there's one final type of object, and M29 down here, oops, sorry, where did M29 go? There it is. M29 on the left hand side here is a very good example of this. Has anybody found out what this is? So it's not a globular cluster. Open cluster, brilliant. Okay, Leela's been doing her research, fantastic. So can you see there's a lot of stars that are close together in the sky, but not so many stars that it's forming the globular cluster in the middle. So these are far fewer stars and tend to be very, very young and therefore very hot objects. You can see M45. M45 is a very famous open cluster. So these are the Pleiades. So if you know anything about classical mythology, the Pleiades were 7 sisters that were the daughters, I think, of the god Poseidon, and he was very upset with them having lots of admirers, and so he put them up in the sky to keep them out of the reach of their admirers. So they're up there. It's a beautiful object to look at. So we've got two examples there: M29, M45. There's lots of others as well. So what we've done here is we made a list of the type of objects that we're looking for. Okay, so we've got M29, M45. Good examples there that we found. So what we're going to try and do in the project is we're going to try and make sure that we get at least one example of each of these, because if we look at the definition or the instruction for the observing task, it says demonstrate the range of objects in the Messier catalogue. Use detailed drawings, so you can do this by eye if you wanted to, or photographs of objects from the Messier catalogue to demonstrate the range of different objects it contains. So ideally we'll try and get one each of these 5 objects, but we might also be able to get examples of different types of galaxies, like elliptical galaxies and spiral galaxies, or more than one example of each one if we can. So that's the first step, is just getting the background knowledge sorted out. So how are we on writing in our own booklets? Do we need a bit more time, or shall I carry on? Carry on? Yep. Matilda, happy for me to carry on? Yep. Okay. So we're going to go to the next page, which has now slipped a bit because I've been typing in there. So let's bring that back up. Okay. So what instrument are we going to use to make our observations? Well, this is pretty easy. I'll just type in here. What we're going to do is use the National Schools Observatory Liverpool telescope. Okay, so that's our equipment basically sorted out. Why have we chosen this instrument? So let's get you to do some work here. So type some suggestions in the chat. Why have we chosen to do it with the Liverpool telescope? Yeah, it might. We're not going to make any measurements, so I don't think I would use the word accurate. Okay, but we might get higher resolution images. Okay, because it's a yeah, we've got access to it, which is good. Okay, and we've got access to it online, which means that it's very convenient to use because we don't have to go there. We don't have to wait, for a good evening or anything. We'll just put our requests in the queue and wait for them to come back. So I think those would be good things to say. So you can write it in your own words if you want. So we can say we can access this telescope remotely. It will give us very high resolution resolution images because it is a 2-meter professional telescope. Okay, so that's something that is very, very unlikely that you would have access to as an amateur, because if you imagine the 2 meters refers to the aperture, which means in this case the size of the mirror. So if you imagine a mirror that big, a concave mirror, 2 meters is just over my height. So if you imagine a tall adult, okay, that's how, and a mirror stretching from their head to the floor, that's a pretty big mirror. That's going to be a very, very expensive thing for an amateur to be able to afford. Okay, so this is a professional grade telescope. What was the other thing I said? Oh, about the weather. Maybe we can put our requests in a queue, so we don't have to rely on waiting for good weather to make our observations. Okay, because that's the other, another problem is if you were doing this yourself, you might think, right, I'm going to do it tonight. You go out and it's cloudy. So this, you just put it in a queue and it waits until there are suitable conditions. Okay, so what I mean as the telescope program will select the best observing time for me. Okay, so those are all good reasons. Oh, there's one other good reason as well. Can you remember where the Liverpool telescope is? Not in Liverpool, funnily enough. It was designed and built in Liverpool, which is why it's called the Liverpool telescope. But then they took it to the Canary Islands and put it on top of Gran Canaria, on top of a very high volcano. Why would they put it very high up? Yeah, so we don't get air pollution, weather, light pollution, and not as much atmosphere. So the atmosphere is going to be clearer, okay, on a volcano in the Canary Islands. That's not how you spell Canary. Canary Islands, where the weather is better, the sky is clearer, and there is less atmosphere to observe through. Okay, so those are good things. So this is all really good evidence of making a plan. Okay, so these are all the kinds of things you need to say in your booklet to show that you've been thinking about it and making a plan. So I think that all looks really good. Now, how are we doing on keeping up with writing things down? Do we need a bit more time, or are we okay? Okay, Leela, okay? Yeah, right. So what we're going to do next is we're going to try and make a list of the Messier objects that we are going to observe or try and ask for request images of. Okay, so I've got this little table in here, and what we're going to do is we're going to see which Messier objects may be visible by the Liverpool telescope, and I'll remind you how to do that in a second. And then we're just going to put a reason for choosing it. Now, the main reason we're going to choose these objects is because they are different examples of the types of objects in the Messier catalogue. So we're going to put things in here like it's a nebula, or it's a galaxy, or it's a spiral galaxy, or whatever. That's the main reason. Okay, so what we need to do now is we need to look at the National Schools Observatory website, and I need to remind you of how to submit an observation. you might remember how to do this anyway, but let's see if we can do some of these together this evening and start writing that information in there. Now, let me just ask you, can you remember what your ID and your password are for the National Schools Observatory? So if you need to log in, can you remember how to do it? Leila's got hers, Matilda hasn't. Okay, so what I'm going to do, Matilda, is I will type a message just to you. I will, right, what I might need to do is I'll stop the share just for a second while I look this up so that I keep your account confidential, because we know that Leila can't be trusted and she might steal your password otherwise. So I'm going to just look up your password. Sorry, Leila, I shouldn't be rude about you. Okay, right, National Schools Observatory. Okay, I can relax again. Right, what we're going to do then is we're going to start setting up an observing program. So when you're ready to do this yourself, we'll put a few observation requests in together this evening, but let's see what's available, and then I can explain to you how to do it. So you go to this Go Observing task tab, and you just press on the top one, and it will come to this Go Observing page. And there are lots of different things that you can make observations of, but we want to do a GCSE astronomy project, so we go to that link, and we're looking for things in the Messier catalogue, so they're going to come under observations of a nebula or a galaxy. And the thing is, for this project, we don't need to make amazing images or color images or anything like that. We just want to get an image of each of these different types of objects. So what we're going to do is say, yes, we've selected that, we know that, so we're going to continue. Okay. Now, what we'll need to do is we're going to set an observation time. Now, if we just set in here 1 week and see next week, come back together and see what's happened, I doubt that we'll get very many observations. We could set a month, but that'll be in the summer holidays and we might not be meeting again. So I suggest that each time you pick 3 months, and that means that your observation request will be in the queue right up until September when we meet again for the new term. Okay, so we'll select 3 months, and that will also give us a better chance of getting some of the images. And then we press continue, and then it will tell us what objects it recommends us to observe in that time period. But remember, what we're interested in is the Messier objects, and so we're going to look for the ones that are in the Messier catalogue. Although some of the others might look fascinating, we're going to try and make a collection of these. So Messier 110 is the first one on here, and it's an elliptical galaxy. So, you know, why not start with that? Let's set up an observation for that, because it's an example of a galaxy, and a galaxy is something that we want to get an image of. So I click on Messier 110. This is where we have to do a little bit of technical input, because now we need to choose how to set up the telescope to get a nice image of that object. So the first thing we have to choose is the exposure time. So what I want you to think about is the time here, 30 seconds. So that means opening the aperture for 30 seconds to let light in, 60 seconds, 90 seconds, up to 120 seconds. So 120 seconds, remember, is 2 minutes. So that's a difference of having the aperture open to collect light for half a minute or for 2 minutes. So we need to think about how bright or dim we expect the object to be. If it's a star cluster, it's going to be made of lots of very bright stars. So what do you think we should set for a star cluster? A short exposure, 30 seconds, or a long exposure, 120 seconds? Ooh, let me go down. Yeah, 30. So Matilda's saying 30. Yeah, because it's going to be very bright, so we don't need to expose it for very long. If it was a dim object, like a nebula, for instance, because a nebula doesn't give out its own light, then we'd go for 120. We want to collect lots of light to make an image. The galaxies are going to be somewhere in between, depending on whether they're, how far away they are, how big an image we're going to get. Now, Messier 110 is an elliptical galaxy, so that's not going to have nice spiral structures and banding in it. It's just like a kind of blob in space. So I would suggest that we choose 90 seconds because it's going to be a fairly dim object, and we'll see what happens with a 90-second exposure. What you could do is you could submit 2 or 3 requests. You could come back again to Messier 110 and try different exposures and see if they look different. The other thing that we need to set is the type of filter over the front of the telescope. So these letters stand for U is ultraviolet, B is blue, G is green, V is what we call visual, R is red, I is infrared, and HA stands for hydrogen alpha. Now, as we're just trying to make an image this time, we want to go for one of these colors that's in the visible range in the spectrum, because that's what we can see with our eyes. It'd be quite interesting to look at infrared or hydrogen alpha, perhaps if we were doing a different type of project, but we just want to get a good image of this object. Now, the interesting thing here is that we've got a green and a V for visual. So these are just basically different wavelengths, very specific wavelengths of light, and visual is the one that is nearest to the peak wavelength that your eye is sensitive to. So this is like peak eye sensitivity. So I suggest that for this project we choose all V's so that we keep the filter the same in all the images we make, so it's a kind of fair test when we come to look at them all. So that's what we will choose for this one, 90 seconds and the visual filter, and then we press continue. Now we've got to decide what conditions we are prepared to accept. So are we going to go for any old rubbish, or are we going to be very choosy about the type of image that we want? And I'm only showing you a couple of examples this evening, because what you can do then is you can go away and set up your own observing program. But just to give you some examples now, the first thing is the sky brightness. Now, if the moon is up, if you've got a full moon, then that's going to cause a lot of glare, and it's going to wash out quite a lot of the sky. So that's going to reduce your chances of getting a good image of the object. Now, it's up to you when you select this, but I would say let's be a bit choosy and just have dark sky conditions when it's new moon, so we've got more chance of seeing that object. The other thing is the seeing conditions. Are you willing to accept a poor atmosphere when there might be a lot of water vapor making it fuzzy, or average to good conditions? What I'm going to do is kind of have a compromise and say I don't want the poor conditions because I don't want fuzzy images. I want to be able to see what they are, but I'll accept average. If we got quite a sharp image, we should be able to see the object. So I'm going to select those two, and I'm going to continue. Now what it does is it just checks with me that I'm happy with the way everything's set up. So it just gives me a summary there of what I've selected. It gives me a little example of an image that's been taken already of this object. So you can see what we're looking for is this elliptical galaxy. So this kind of explains why I've chosen quite a long exposure, because it's got a lot of gas and dust in a big blob around it, which is not going to be very bright, and why I've thought I don't want moonlit conditions, because that will wash out any image that I do take. So we're just going to go for dark conditions. So I'm quite happy with that. Oh, it gives me a little chart to show me what my chances are of getting this image over the 3-month period that I've selected, and it looks like there are some times in mid-August and early September, oh sorry, that's not mid-August, that's the end of July, beginning of August, end of August, beginning of September, when I've got some fairly good chances. Here's the key, excellent chances actually of getting that image. So I'm all happy with that, and what I'm going to do is submit it, and it's gone into the program. And then what I will do from time to time is I'll go back to the Go Observing tab, and I'll have a look at my observations and see if it tells me that my observation has been made or not. So if I have a look at that now, it will show me the list. These are old ones that I've done in the past, but this is the new one that we just did, and it says it's submitted. And then the next thing it will say is it's been sent to the telescope. And then if they actually make the image, you'll come up with this ready to download tab, and then you'll be able to have a look at your observation like this. And there it says, right, it's all been taken. There it is, observation details, and it's available to download. So you go to that link there, and there it is. So this was a nice little image of the Dumbbell Nebula that I managed to make. Okay, now the next problem is that these images come in a special format called a FITS format, which is a special astronomical format because they contain a lot of information about the image. It's not just a picture like a JPEG. So you can't just look at that image. What you'll see if I click on this is that it just downloads as a FITS image. So it's got this FITS extension on it, not JPEG. So that's a bit of a problem because if I click on that, it's not going to do anything because I haven't got any software that's going to open it up. It's going to say couldn't be opened because it can't find that that file format. So what you will need is some software to be able to open it. There's two ways you can do this. Oh, actually, because I've got that software on my computer already, it has automatically gone to it. That won't happen for you. So last thing I'm going to show you is a suggestion for some software that you can use, that you can download and use to open up these images to check what they look like, because it's a bit frustrating if you get your image and then you want to look at it and you can't. Okay, so the software that I suggest is this one, which is called Salsa J, and you go to this website. I'll put the link into the chat for you if you want to copy that. Okay, there it is, Salsa J, and it's freeware that you can download. It explains a lot about it here, but here it's got download just there. Okay, and then you can pick your device. And the good thing about this is it will work on Windows or on Mac. The software that the National Schools Observatory supply will only work on a PC and not on a Mac. So you can download it. Now I've already downloaded it, so I won't show you that. What I will show you is what happens. It goes to my desktop. Let me find my desktop, move everything out of the way. Don't need this folder open. Let me close that. I'll close that. Let me look for my desktop. There it is. Hopefully you can just see a bit of my desktop there around the edges. And this is it. It's come up as an app on my desktop. So when I open that, what will happen is this. So when if you download that and install it, this is what you'll get. And what you need to do is to click on this Salsa J tab, and then it says, do you trust it? I would say it's fine. It's been made by a reputable source, so you can open it, and then it does all this stuff. It's running some programs to start it all up. Really important thing is never ever shut this when you're trying to use Salsa J. And then it opens up this little menu bar. Okay, so just ignore this and leave it there, otherwise it stops working. And what we can do in the menu bar is go and look for a FITS file. So here's a where's the FITS file that I have opened today? So we're looking for Thursday the 30th of June. Here it is. This is the one that I just downloaded. Okay, that was my Dumbbell Nebula picture. So I'm going to open that one with Salsa J. And oh, actually it wasn't the Dumbbell Nebula one, was it? Oh, it might be another one that I've been looking at today. I think this is a different one anyway. I think this was an open cluster, but there it is. It opens up, so it's now opened that FITS file so that you can look at it, look at the images that you've got. Okay, that's not the most exciting one. What I might do is look for a more exciting one. I'm going to shut that one. just to show you a few other things you can do with Salsa J. So let's look for, why hasn't it got that Thursday that, oh, maybe it was this one. Let's see if that's the one I've just, yeah, there it is. There's the dumbbell nebula. So it's very nice. We can make it bigger, and it looks a bit faint. Okay, quite hard to see. So that probably means that I didn't get my exposure time quite right. Okay, but what you can do up here is you can go to image, and you can go to adjust, and then you can adjust the brightness and contrast in this way here. So you can just try an automatic one, and there you see it's now brought it up a little bit more brightly so you can see it. Or you can try fiddling yourself with these slider bars to see if you can bring it up a bit better. So now if I do that, you can see some of the dust around here that gives it its name, the dumbbell nebula. And what I could do is just fiddle around with that image a bit until I'm a bit happier with what I'm looking at, and I can see some of the structure of the handles on the side of the dumbbell. The other thing I can do on image is I can look at show info, and that tells me a little summary of all the things I chose. What it is, it's Messier 76 that I set 120 seconds exposure time. I used a clear filter in this case, and when the observation was made. So that's all the information that I will need later on when I'm looking at my images and analyzing how good they are. So that is a kind of quick lesson on the next step in the project, but really it's up to you to set up an observing program in the using the National Schools Observatory website. Okay, so what you need to do is go to NSO and go observing and make up your own observing program using this link and going for the nebulae and galaxies, putting in there that we're gonna observe for 3 months, and then just going down this list and one by one selecting Messier objects to go into the catalogue and into your program. So there's quite a few of them there. But one more thing before we finish: each time you put one in, be very careful to record what you've done in this table so you can see which ones you're going to do, which Messiers you've chosen, and your reason for choosing them. And on the next page, when you actually submit them to the program, make a record of the object, the exposure time you chose, the filter that you chose, the sky brightness conditions, was it dark or bright, and the seeing conditions that you chose, average, good, fuzzy, whatever. Okay, so try and do that in advance if you can. Obviously when you get the images, you will be able to look at that little information panel and find out all this information afterwards if you did forget to do it. But try and make a record as you go along of all the ones that you've chosen. And the big thing to remember is try and get an example of each different type of Messier object. So these 5 different types: a galaxy, a planetary nebula, diffuse nebula, globular cluster, open cluster, and maybe at least 2 of each, so if there's more chance of getting an image. So that's the plan, and we'll have another chat about this next week and see how we've got on with it. Okay, and see whether we've got any images or not. So I'm going to stop there for this evening. Unless you've got any questions for me, then I will speak to you next week. Okay, thanks. Bye. Bye, Leela. Thank you.